Okay, we continue with the next speaker, and we have also a very big company here represented, and it's great to see, especially GCL speaking, which is also one of the world's largest silicon producers, so they really control it from the beginning. And we have with us Rojen Malachi, who is the technical director at GCL SI, and he will present now about power that lasts, understanding reliability at GCL. Rojen, the floor is yours.
Yep, I'm just trying to share my screen. Do you see my screen?
Yep.
Okay, great, thank you. Okay, you also hear me?
Yeah, all perfect.
Okay, great, then I can start. So, welcome everyone. Today we are going to explore the reliability of GCL PV modules. This is going to be an essential topic for anyone involved in the solar energy projects. My name is Rojen Malachi and I'm working for GCL and I'm based out of Munich in Germany. I'm excited to walk you through GCL's approach to ensuring long-lasting, efficient performance of our solar products. Over the course of the next 15 minutes, I'm going to be talking about the importance of why is reliability important, GCL's design and manufacturing innovations, our rigorous testing and quality, our reliability enhancements, and closing off with the claim ratio and our case studies. Just a brief introduction about GCL. We are a technology leader in the global energy sector with more than 30 years of experience and $28 billion of asset value. We're part of the top 500 energy company, managing a diversified portfolio that includes semiconductor materials, energy, and of course, solar PV manufacturing. Our mission is to deliver reliable energy solutions worldwide. Here we provide a snapshot of GCL's extensive manufacturing capacity, showcasing our integrated supply chain from silicon to module. This includes fluidized bed reactor or FBR silicon production capacity that stands at an impressive 420,000 tons annually. This is the foundational material for our entire production chain, ensuring we control quality from the very start. We have a production wafer capacity of 58 gigawatts, the N-type cell capacity of 20 gigawatts, and finally a module capacity standing at 30 gigawatts. As you can see, GCL is fully integrated and from the silicon to the finished modules, which enables us to maintain strict quality controls, ensuring reliable and high performance photovoltaic modules for the global market. Next, I'm going to be talking about the importance of module reliability. Module reliability is critical for the success of any PV system. A 2021 International Energy Agency report showed that 27% of reported O&M tickets are related to module failures. Common issues including junction box, diode failures, cell cracking, hotspots, glass breakage, mechanical load failures, and PID degradation. These failures can result in substantial energy losses and higher operating costs. I think the key here is the impact of the energy yield and the life cycle costs, and also decreasing the OPEX by minimizing module-related issues, and also reducing uncertainty and system degradation, ensuring you get a better return on investment. Talking about return on investment, I think the critical component here is the LCOE, or the levelized cost of electricity. Some important metrics here are the module degradation. The yearly module degradation could be around 0.25, 0.3, or even 0.4%, depending on the module type and the environment. And you have the O&M costs. These are typically, I don't know, 10, 12, 15 euros per kilowatt peak per year that an O&M company charges. And of course, energy yield, which directly influence, which also the energy yield is the amount of energy that a system generates over its lifetime. And this, of course, has a direct influence on the LCOE. The formula at the bottom of the slide breaks down the LCOE calculation, and it factors in the total life cycle cost, including the initial investment, the annual costs, and the residual value, and compares that to the total energy over the system's lifespan. So the system degradation plays a key role, as a higher degradation rate leads to a lower energy yield, which negatively affects the LCOE. Reliability also helps to reduce the uncertainty for investors. With lower annual costs due to fewer failures and reduced system degradation both contribute to minimizing the financial risk, which makes a solar project more predictable and stable in terms of returns. Now that we understand the financial implications of module reliability, let's move on to specifically addressing the how GCL addresses these challenges. In this section, we look at the design and manufacturing innovations at GCL. As you know, the performance and longevity of a solar module depends on the quality of its component. At GCL, we employ rigorous quality control procedures at every stage of the manufacturing process. To start with, you have the incoming quality control inspections. So this includes pretty much every single one of the incoming materials. This would be the glass, the cells, the backsheet, EVA, frame, and junction boxes. These tests are done periodically. Pretty much for 100% of the batch are tested before they go into the production line. Additionally, there are also tests that are conducted, sequence tests like the TC100 or the HF10, and of course damp heat 1000 tests for the junction box are conducted to assess their mechanical and electrical properties. Finally, the finished modules, after their assembly, they undergo a series of finished module tests to ensure their overall performance and reliability. These include classical tests like PID, LETID, and of course sequence tests that includes damp heat 1000, TC200, and hail tests. By subjecting the modules to these rigorous tests, we can identify any potential issues and take corrective actions to ensure that only high quality products reach the end customer. By rigorous testing of both the raw materials and the finished modules, we can ensure that the modules have the desired quality and of course, we're able to provide the performance and the product warranty. Another important aspect of manufacturing is the use of robots. As shown in the table, robots are being employed in a variety of tasks, including stringing, layup, outgoing bar handling, glue cleaning, and assembling the junction box. The total number of robots used in these processes are a total of 24, demonstrating their significant contribution to the production line. In addition to robots, AI systems are also being integrated into manufacturing process to ensure quality control and inspection. AI-powered vision systems are used to inspect the modules at various stages, such as after soldering, before and after lamination, during the junction box soldering process. These steps help identify defects and inconsistencies, ensuring that only high-quality products reach the market. The use of robotics and AI in solar module manufacturing offers several key benefits, including increased efficiency and productivity, improved product quality, enhanced consistency, and repeatability. Robots handle repetitive and precise tasks, reducing human error and increasing production speed. AI systems ensure rigorous quality control, detecting defects early and maintaining high standards. As we continue to see advancements in robotics and AI, we can expect even more innovative applications in the solar industry in the years to come. One of the ways we assure quality is via the use of third-party independent test institutes. In this regard, GCL is proud to be named a top performer in Kiva's PVEL 2024 PV Module Reliability Scorecard. Independent third-party tests show that our modules outperform industry standards, especially in critical LETID and thermal cycling tests. The results here speak for themselves, with an LETID degradation at 162 hours of less than 0.2%, a thermal cycling TC600 of less than 2.74%, which is several times the IEC, and also sequence tests including dynamic load of less than 0.8%, which these are all far below the 5% standard required by the IEC. Our lab is equipped with advanced testing equipment and is accredited by renowned global certification authorities. The tests that we conduct in our lab include wet leakage current test, walk-in chambers that simulate various environmental conditions such as temperature, humidity, UV exposure, water spray test, hail test, and most of these tests come from the IEC 61215 and also extended reliability testing. To ensure that the credibility of the testing results, our lab is accredited by several globally recognized certification authorities, including TÜV Süd, TÜV Rheinland, CSA. Accreditation guarantees that our testing procedures are equipped and equipment meet the highest international standards. This provides our customers with confidence in the quality and reliability of our solar products. I'd like to discuss the accelerated aging test conducted on one of our modules, the GCL NT1072 GDF solar module. These extended reliability tests are designed to simulate long-term effects of harsh environmental conditions and ensure the durability and reliability of our products. As shown in the chart, we subjected the module to a variety of accelerated aging tests, including damp heat 3000, salt mist 8, PID 192 hours, dynamic mechanical load, TC 600, UV 60, and LETID 648 hours. These are several times the IEC standard. The results demonstrate that our module exhibits excellent resistance to these aging factors, significantly outperforming the IEC standard limit of 5% power degradation. GCL has set an internal limit of 3% or even less, sometimes it's 2.5% power degradation, which our module easily meets. For example, the damp heat 3000 test, the module experienced only 1.6 power degradation. In conclusion, the accelerated aging test confirmed the exceptional durability and reliability of GCL NT1072 GDF. Next, I'd like to discuss the technical improvement GCL has made on TOPCon cells to enhance their efficiency and reliability. I think TOPCon is pretty much the industry standard. More than 2/3 of the market of the solar industry right now is using this cell technology. We also incorporate what is called as a laser enhanced contact optimization. This basically precisely controls the heat affected area during the laser processing. This improves cell efficiency, reducing the power losses and minimizing the formation of cell cracks. And we also use the industry standard SMBB, or the super multi-busbar technology, which basically reduces the distance between bus bars, shortening their current transmission path, and decreases the internal resistance and power loss, improving the overall cell efficiency. So with both of this technology, we're able to basically increase the module efficiency between 1 and 1.5%. So a combination of SMBB and also LECO and also our advanced TOPCon cell technology. Talking about reliability, another important improvement is the use of non-destructive cutting process, which basically reduces the cell-to-cell distance from a 2 millimeter to 0.8 millimeter. This is achieved without forming a cutting surface on the edge of the cell. The key benefit of this process is that it minimizes the damage to the cell. By avoiding the formation of a cutting surface, we reduce the risk of welding cracks and fragments. This leads to a higher yield in the manufacturing process. Additionally, the non-destructive cutting process helps in maintaining the structural integrity of the cells. This results in lower power loss and improved overall efficiency of the cell and modules. Next, I'd like to talk about the reliability in real-world applications, and also maybe starting off with our claim ratio. From 2015 all the way to mid-2024, GCL modules have maintained an impressively low claim ratio of less than 0.05%. So this basically means that less than 0.05% of the modules that have been reported for issues or defects over this period. The low claim ratio is the testament to the high quality that GCL provides for its module. It reflects our commitment to rigorous quality control and continuous improvement in our manufacturing processes. Let's move on to the next section where we discuss actual case studies where GCL modules have been used. This is a project that is in China on a rooftop with around 3.8 megawatt power DC. The modules used are the GCL M1072 GDF. and the project came into operation in December 2022. So if you look at the graph here, the expected performance ratio and also the expected yield are in reality are far better than what was actually estimated. This basically shows the quality and also the yield that GCL modules produce. And also another actual case study for an 8.6 megawatt rooftop project that went live in December 2022. Here too, the actual performance ratio exceeds what was expected, and also the yield is also higher than what was expected. So in summary, I went through the different aspects of GCL as a company, how it's important to be vertically integrated in terms of having the raw silicon all the way to the actual materials. We talked about the different module design innovations, the robust design, the incoming quality control, the outgoing quality control, and also the use of robots and AI in manufacturing. And we talked about also our impressive claim ratio. So that is it from my side. I'd be happy to take questions.
Thanks, Rojen.